Welcome to today's ArXiv Computer Science Digest for May 28, 2026. We received 1,147 new computer science papers today across 61 subfields. Let's dive into the top picks. Trend 1 of 10, System Reliability and Trustworthiness. This trend explores methods to build, assess, and maintain dependable and secure systems, ensuring their integrity and performance. This cluster covers 57 papers. Representative work includes GRAM, assessing sabotage propensities via automated alignment auditing, zero-skin data quality, leveraging table format metadata for continuous observability at scale, and generalizing a highly configurable analytics pipeline to replicate and support educational research across multiple domains. Trend 2 of 10, Advanced Diffusion Models and Sampling. Exploring novel diffusion model architectures, advanced sampling strategies, theoretical analysis, and diverse applications across various domains. This cluster covers 87 papers. Representative work includes colored noise diffusion sampling, when, why, and how do diffusion posterior samplers fail, a finite sample lens, and Mirage atom diffusion for de novo crystal generation. Trend 3 of 10, Dynamic 3D/4D vision and generation. Advancing the perception and generation of dynamic 3D/4D visual content, encompassing motion and spatiotemporal understanding. This cluster covers 132 papers. Representative work includes GMOS, grounding moving object segmentation in 3D space and time, VideoMLA, low-rank latent KV cache for minute-scale autoregressive video diffusion, and DynaFLIP, rethinking robotics perception via trimodal dynamics guided representation. Trend 4 of 10, AI for scientific discovery and reasoning. AI is increasingly applied to automate, assist, and enhance scientific discovery, reasoning, and research processes across diverse fields. This cluster covers 101 papers. Representative work includes Physics is All You Need, a case study in physicist-supervised AI development of scientific software, benchmarking single-factor physical video-to-audio generation, and composing future theorems from citations and formal structure. Trend 5 of 10, Theoretical Computer Science Foundations. Explores foundational mathematical and logical principles governing computation, information, and algorithmic processes. This cluster covers 89 papers. Representative work includes majorization precursors to supermodularity and subadditivity on the majorization lattice, reasoning with sampling, cutting at decision points, and on language generation in the limit with bounded memory. Trend 6 of 10, Generative AI for practical applications. Generative AI models are applied to solve diverse real-world problems efficiently and reliably. This cluster covers 135 papers. Representative work includes SCHGen, PCB schematic generation with semantic-grounded code representations, tiny but trusted, efficient vision language reasoning for time series anomaly detection, and GPIC, a giant permissive image corpus for visual generation. Trend 7 of 10, LLM training, reasoning, and efficiency. This trend explores methods to enhance large language model training, reasoning capabilities, and overall operational efficiency. This cluster covers 213 papers. Representative work includes LLM Surgeon, diagnosing data mixture of large language models, unlocking the working memory of large language models for latent reasoning, and efficient test time fine-tuning of LLMs via convex reconstruction and gradient caching. Trend 8 of 10, LLM agents and multi-agent systems. Papers explore the design, evaluation, and optimization of large language model agents, including their interactions in multi-agent systems. This cluster covers 119 papers. Representative work includes locally coherent, globally incoherent, bounding compositional incoherence in multi-component LLM agents, SpecBench, evaluating specification-level reasoning for software engineering LLM agents, and Agent Dropout v2. Optimizing information flow in multi-agent systems via test time rectifier eject pruning. Trend 9 of 10, Advanced ML, Fairness, Efficiency, Interpretability. Advanced ML research explores fairness, efficiency, and interpretability. Trend 10 of 10, AI for complex real-world systems. Applying AI and computational methods to understand, optimize, and solve problems in diverse, complex real-world systems. This cluster covers 74 papers. Representative work includes enhancing structural resilience in healthcare through patient flow network, RoboWits, unexpected challenges for robotic creative problem solving, and a heterogeneous architecture for robot RL beyond GPU-dominant paradigms. Contribution 1. Analysis of world model limitations. Current long video generation models have limited world modeling capabilities due to two main challenges: compounding errors and insufficient memory mechanisms. This understanding is derived by enhancing image-to-video models with action conditioning and an autoregressive framework, observing that compounding error is irreducible and memory issues cause incoherence. This analysis illuminates fundamental challenges in video world models, providing critical insights into why existing methods struggle with long, interactive, and consistent video generation. Contribution 2. Video Retrieval Augmented Generation, VRAG. The paper proposes Video Retrieval Augmented Generation, VRAG, a novel method for enhancing interactive video generation. VRAG achieves this by employing explicit global state conditioning, which helps to maintain a consistent understanding of the environment over time. VRAG significantly reduces long-term compounding errors and increases the spatiotemporal consistency of world models, outperforming naive autoregressive generation and standard retrieval augmented generation. Contribution 3. Benchmark for world models. A comprehensive benchmark is established for improving video generation models with internal world modeling capabilities. This benchmark is formed by evaluating various approaches, including VRAG, against the identified challenges of compounding errors and memory mechanisms in interactive video generation. The benchmark provides a standardized framework for future research to evaluate and advance interactive video generation and world model development, fostering progress in the field. Up next, our second paper out of 10, Latency Quality Routing for Functionally Equivalent Tools in LLM Agents by Kersen Chu and Wei Zhang from University of Connecticut. This paper was selected because it addresses a critical and increasingly pressing operational challenge in the deployment of LLM agents by introducing a novel contextual bandit router for managing functionally equivalent tools under runtime constraints. Let's break down its key contributions. Contribution 1. LQM Context Route for Tool Routing. The paper introduces LQM Context Route, a contextual bandit router specifically designed for same-function tool providers in LLM agents. It achieves 0.583 f1 at 431 milliseconds in a search API pool while remaining on the latency quality frontier. This router employs latency quality matching, ranking providers by their expected answer quality per service cycle rather than using simple additive rewards. It integrates capacity-aware scoring with query-specific quality estimation and LLM as judge feedback. This novel approach allows for online adaptation to both load changes and provider quality differences, addressing limitations of prior quality blind priority/fallback policies. Contribution 2. Superior performance in heterogeneous settings. LQM Context Route demonstrates significant performance improvements across various tasks, including web search, strategy QA, and heterogeneous retriever pools. The core mechanism involves treating latency as service capacity rather than an additive reward offset, which prevents additive reward collapse where low latency might mask poor answer quality. It improves F1 by plus 2.18 pp over SWCB on web search, accuracy by up to plus 18 pp over SWCB on strategy QA, and NDCG by plus 2.91, plus 3.22 pp over SWCB on retriever pools, showcasing its robustness in diverse quality settings. Contribution 3. Formalizing Provider Routing Problem. The paper identifies and formalizes the same function provider routing problem for tool-augmented LLM agents, where multiple functionally equivalent providers exist for a single tool interface. This problem is characterized by the need to choose among providers that differ in latency, reliability, and answer quality under runtime load, often without deployment time gold labels. This work highlights a critical gateway decision in LLM agent design, moving beyond tool type selection to address the practical challenges of provider choice in dynamic, real-world scenarios. Up next, our third paper out of 10, Open Problem, Separating Geometric and Algorithmic Compression via Cayley Table Completion by Dongsung Ha. This paper was selected because it identifies a fundamental limitation of current deep learning models in handling algorithmic complexity, proposing a novel theoretical testbed that could significantly advance our understanding of AI's inductive biases and pave the. Let's break down its key contributions. Contribution 1. Failure of geometric priors. Deep learning consistently fails to extrapolate exact algorithmic or discrete algebraic rules, revealing a missing inductive bias. Modern statistical learning theory, SLT, relies on geometric compression via continuous capacity control, e.g., norm-based regularization, which is effective for continuous data but not discrete algebraic domains. This theoretical misalignment shows that current deep learning methods are fundamentally limited in tasks requiring discrete algebraic reasoning. Contribution 2. Cayley table completion testbed. The Cayley table completion problem is proposed as a canonical testbed for investigating the missing algorithmic bias in deep learning. It functions as the discrete algebraic counterpart to matrix completion, a well-established problem in continuous geometric compression. This provides a concrete, structured problem to develop and evaluate methods for algorithmic complexity minimization in discrete domains. Contribution 3. Flatness prior for associativity. Recent results demonstrate that operator-valued tensor factorizations combined with a flatness prior yield an implicit algorithmic bias. This approach specifically induces a bias toward exact discrete associativity, showcasing a mechanism for discovering discrete algebraic rules. This suggests a promising direction to generalize continuous flatness priors to autonomously discover broader discrete algorithmic axioms, moving beyond combinatorial search. Contribution 4. Open problem, recovery bounds. The paper poses the open problem of establishing formal exact recovery bounds for Cayley table completion. This requires generalizing continuous flatness priors to autonomously discover broader discrete algorithmic axioms without relying on combinatorial search. This challenges the community to develop rigorous theoretical guarantees for algorithmic compression, akin to those established for geometric compression in fields like compressed sensing. Up next, our fourth paper out of 10, Less is More, Elevating RAG via Performance-Driven Context Compression by Ziqiang Cui and Chun Ma from City University of Hong Kong. This paper was selected because it introduces a novel performance-driven context compression method that directly addresses a critical and widely recognized efficiency bottleneck in retrieval-augmented generation, RAG4. Let's break down its key contributions. Contribution 1. Core RAG Context Compression Framework. CoreRAG is a novel framework designed for context compression within retrieval-augmented generation, RAG systems. It operates by eliminating reliance on proxy heuristics, instead employing a performance-driven learning framework that directly uses task performance as a feedback signal to refine its compressor policy. At a high compression ratio of 3%, Core RAG not only avoids performance degradation but also improves the average exact match, EM, score by 3.3 points compared to using full documents. Contribution 2. Performance-driven learning for compression. CoreRAG introduces a performance-driven learning framework for optimizing context compression in RAG. This framework directly utilizes task performance as a feedback signal to iteratively refine the compressor policy, moving beyond static, predefined heuristics. This mechanism enables Core RAG to achieve superior results with significant context compression, demonstrating a 3.3 EM point improvement at a 3% compression ratio. Contribution 3. Knowledge distillation for policy initialization. CoreRAG incorporates a knowledge distillation phase to initialize its compressor policy. This phase aims to provide a robust initial policy for the compressor before the iterative performance-driven optimization process begins. This strategic initialization likely contributes to the stability and effectiveness of the subsequent learning, enabling the system to achieve high compression ratios without compromising task performance. Up next, our fifth paper out of 10, HaloNet, Learning Hallucination Risk from Internal Signals in LLM Question Answering by Xiaodong Tong and Yambing Liu from Institute of Information Engineering, Chinese Academy of Sciences. This paper was selected because it introduces a novel and lightweight method, HaloNet, to estimate hallucination risk in large language models using only internal signals, directly addressing one of the most critical and pressing challenges. Let's break down its key contributions. Contribution 1. HaloNet Performance. HaloNet is a lightweight hallucination risk estimator that provides an answer-level risk score for LLM question answering. It jointly models internal signals, including token likelihood, predictive entropy, and hidden state information from a single generation trace. On a 300-example human evaluation, HaloNet achieved 0.874 ROC and 0.869 AUPRC, with its top 20% highest risk answers containing 96.5% errors, yielding a 2.06x lift over the base error rate. Contribution 2. Scalable Training Methodology. A scalable weak supervision method using LLM as a judge labels was developed for training HaloNet. This approach leverages the capabilities of other large language models to generate supervision signals for hallucination detection. This training method enables efficient and scalable training of hallucination detectors, reducing reliance on costly and time-consuming human annotations. Contribution 3. Real-time efficiency. HaloNet provides real-time hallucination risk estimation for LLM-generated answers. It operates by analyzing internal signals from one model generation, avoiding external verification or repeated sampling. This approach significantly reduces the inference cost and computational overhead compared to existing methods, making it suitable for real-time QA applications. Up next, our 6th paper out of 10, When Models Learn to Ask Why. Adaptive Causal Reasoning for Trustworthy Medical Vision Language Models by Jianxin Lin and Yuan Shui from The Ohio State University. This paper was selected because it introduces a novel adaptive causal reasoning mechanism for vision language models, directly addressing the critical and pressing problem of trustworthiness and reliability in high-stakes medical AI by mitigating spurious correlations. Let's break down its key contributions. Contribution 1. MedCausalX Framework. MedCausalX is an end-to-end framework that explicitly models causal reasoning chains within medical vision language models, VLMs. It integrates a two-stage adaptive reflection architecture with causal and verify tokens and optimizes a trajectory-level causal correction objective using error-attributed reinforcement learning. This framework consistently outperforms state-of-the-art methods, achieving a plus 5.4-point improvement in diagnostic consistency and over 10 points reduction in hallucination. Contribution 2. CRM Causal Reasoning Dataset. The CRM dataset was introduced, providing fine-grained anatomical annotations, structured causal reasoning chains, and counterfactual variants. This dataset guides the learning of causal relationships by offering high-quality causal spurious contrastive samples, moving beyond superficial correlations. CRM addresses a core challenge in medical COT reasoning by enabling models to distinguish genuine causal dependencies, thereby enhancing clinical reliability. Contribution 3. Adaptive Reflection Architecture. MedCausalX incorporates a two-stage adaptive reflection architecture equipped with specific, causal, and verify tokens. This architecture empowers the model to autonomously determine when and how to initiate causal analysis and verification during its reasoning process. It effectively addresses the challenge of adaptively triggering causal correction, making the model more robust against spurious correlations and improving diagnostic trustworthiness. Contribution 4. Trajectory-level causal correction. A trajectory-level causal correction objective is optimized within MedCausalX using error-attributed reinforcement learning. This objective refines the model's reasoning chain, enabling it to differentiate between genuine causal dependencies and mere shortcut associations. This mechanism ensures causal consistency across reasoning trajectories, significantly contributing to the model's reduced hallucination and improved diagnostic accuracy. Up next, our 7th paper out of 10, Latent Performance Profiling of Large Language Models by Tanmoy Chakraborty and Mayank Vutz from Indian Institute of Technology, Delhi. This paper was selected because it addresses the critical and pressing problem of robustly evaluating large language models beyond superficial benchmarks, offering a novel approach to understand their latent performance and processing mechanisms. Let's break down its key contributions. Contribution 1. Latent Performance Profiling, LPP. The paper introduces Latent Performance Profiling, LPP, a novel framework for state-centered intrinsic assessment of large language models. LPP derives task-agnostic diagnostics by defining scalar metrics on a model's hidden activations and output distributions, analyzing its latent representations and dynamics. This framework provides stable, architecture-sensitive signatures that enable interpretable comparisons and uncover hidden vulnerabilities, moving beyond surface-level accuracy. Contribution 2. Empirical Validation of LPP. Extensive empirical analyses were conducted across 8 LLMs, ranging from 0.5B to 14B parameters, to validate the LPP framework. The analysis demonstrated that models with similar benchmark scores can exhibit contrasting latent profiles, such as differences in entropy or adaptability, when assessed with LPP. This finding reveals that accuracy alone offers a limited view of LLM capabilities, underscoring LPP's value for reliable model selection and deeper understanding. Contribution 3. Synthetic Probes for Intrinsic Traits. The research designed synthetic probes specifically for evaluating uncertainty and symbolic reasoning in LLMs. These probes were guided by insights from LPP's intrinsic metrics, ensuring their alignment with the model's latent profiles rather than just output performance. This approach enables evaluation that decouples from leaderboard bias, offering a more robust and interpretable assessment of specific model behaviors beyond standard benchmarks. Up next, our 8th paper out of 10, Token Inflation: How Dishonest Providers Can Overcharge for Large Language Model Usage by Shaheen Al-Haq and Nusia from University of Tennessee, Knoxville. This paper was selected because it identifies a critical and timely vulnerability in the commercial large language model ecosystem, exposing a fundamental lack of auditable transparency in per-token billing that has significant economic and trust implications for users. Let's break down its key contributions. Contribution 1. LLM Billing Trust Paradox. The paper identifies a trust paradox in auditing per-token billing for commercial LLMs, where current frameworks are inherently flawed. LLM providers hide the model, tokenizer, and execution to protect IP and privacy, forcing auditors to rely solely on provider-supplied proofs and consistency checks of self-reported data. This design makes LLM billing hard to audit, creating an environment ripe for providers to manipulate reported token counts and potentially overcharge users. Contribution 2. Quantifying Hidden Reasoning Inflation. The study quantifies that providers can systematically inflate billed token counts for hidden reasoning usage without detection by existing auditing frameworks. In the most permissive setting, providers can inflate these hidden tokens by 1,469% on average by manipulating unseen intermediate steps, exploiting the lack of transparency in LLM operations. This inflation can turn an honest 100 bill into roughly a 1,569 bill for the same query, demonstrating a significant economic vulnerability for LLM users. Contribution 3. Tokenization Ambiguity Overreporting. The research reveals that tokenization ambiguity alone allows for significant overreporting of token counts, even when users can see the full reasoning string. Differences in provider-specific tokenizers or subtle manipulations of text tokenization lead to varying token counts for identical visible outputs, exploiting the lack of standardization. This ambiguity enables 50.85% overreporting below the detection threshold, indicating that users are susceptible to substantial undetected overcharges even with partial transparency. Contribution 4. Solutions for Honest LLM Billing. The paper proposes that restoring honest LLM billing requires verification methods that tie reported token counts to evidence the provider does not control. This can be achieved through trusted execution attestation, cryptographic proofs of inference, or third-party re-execution, providing independent and verifiable token usage data. These solutions aim to overcome the trust paradox by introducing external, verifiable evidence, ensuring fair pricing, and preventing providers from manipulating token counts. Up next, our 9th paper out of 10, Value Flow: Measuring the Propagation of Value Perturbations in Multi-Agent LLM Systems by Jinhua Liu and Hua Shen from Center for Data Science, NYU Shanghai, New York University. This paper was selected because it introduces a novel framework, Value Flow, to measure value propagation and drift in complex multi-agent LLM systems, directly addressing a critical and pressing challenge in AI safety. And let's break down its key contributions. Contribution 1. Value Flow Framework for Value Drift. Value Flow is a perturbation-based framework designed to measure value drift in multi-agent LLM systems. It utilizes a 56-value valuation dataset derived from the Schwartz Value Survey and an LLM as a judge protocol to score agent value orientations. Value Flow provides a principled basis for auditing and mitigating value propagation in deployed multi-agent systems, addressing a previously poorly understood challenge. Contribution 2. System-level value alignment property. The research discovered that value alignment in multi-agent systems is fundamentally a system-level property, not solely an agent-level one. Experiments across value dimensions, backbones, personas, and topologies demonstrated that susceptibility varies sharply and is strongly shaped by interaction structure. This finding indicates that individual agent alignment metrics are insufficient, as interaction topology can lead to unintended system-level value drift despite isolated agent alignment. Contribution 3. Novel susceptibility metrics. Value Flow introduces two novel metrics, beta susceptibility and system susceptibility, SS, to quantify value propagation. Beta susceptibility measures an agent's sensitivity to perturbed peer value signals, while system susceptibility, SS, quantifies the effect of node-level perturbations on final system outputs. These metrics enable the decomposition of value drift into distinct agent-level and system-level components, offering a granular understanding for auditing and mitigation. Up next, our 10th paper out of 10, Safe Search, Automated Red Teaming of LLM-Based Search Agents by Jianxua Dong and Han Xiu from Tsinghua University. This paper was selected because it addresses a critical and emerging safety vulnerability in LLM-based search agents by proposing an automated red teaming framework, which is paramount for the responsible deployment and trustworthiness of rapidly evolving AI technologies. Let's break down its key contributions. Contribution 1. Automated Red Teaming Framework. The paper introduces Safe Search, an automated red teaming framework designed for the safety evaluation of LLM-based search agents. Safe Search operates as a scalable, cost-efficient, and lightweight framework, enabling sandboxed safety evaluation of agents by simulating unreliable search results. This framework overcomes the labor-intensive and cost-inefficient nature of prior evaluation methods, offering a practical approach to enhance LLM search agent safety. Contribution 2. High vulnerability in search agents. The study discovered substantial vulnerabilities in LLM-based search agents, with an attack success rate, ASR, reaching 90.5% for GPT-4.1 mini. This was revealed by evaluating 3 search agent scaffolds across 17 LLMs using 300 test cases generated by Safe Search across 5 risk categories. This quantitative finding highlights a critical safety concern for real-world LLM applications, demonstrating that agents are highly susceptible to unreliable search results. Contribution 3. Ineffectiveness of common defenses. The research found that common defenses, such as reminder prompting, offer limited protection against unsafe outputs from search agents. This conclusion was drawn from evaluations conducted within the Safe Search framework, which systematically tests agent responses to unreliable search results. The finding challenges current assumptions about LLM safety mechanisms, indicating that more robust and effective defense strategies are needed for search agents. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow.